Is it visible now?
Yes.
Okay. So what I was saying, I was covering encoder and decoder. So encoder is and decoder. If we recollect from the lecture, professor had given various examples. For example, one was image, and the task is to describe it here, give a brief description of this image or the captioning of this image. So what do we do? The encoder basically derives the information from this image using the CNN. So we utilize CNN, and then we use FC7, fully connected layer 7, and then we give it as S0 to RNN, and then we train this model. This is part
Yes.
is clear. So this is
Yes.
the encoder part, and this is the decoder part. Okay. So this you can see various examples of what the professor had given, and one example was machine translation. Machine translation, for example, input is, for example, he gave मैं घर जा रहा हूँ, and task is to output should be I'm going home. Going home. So if we see the standard encoder and decoder, what will happen in encoder? This is the encoder. We will feed मैं जा रहा and so what the standard encoder does, it encodes in one go and then feeds this output which is there to the decoders all the parts. This is output. So here will be I am going home, and here will be stop. Here will be I am going home. So basically, the motivation for this attention mechanism, this encoder decoder part is clear, okay? Or do I have to cover it again? The basic concept. Hello, hello.
Sir, could you just repeat in brief once more?
Okay. So encoder, what do we do? For example, I'll give you another example. So this was the image example. We have to give the description of the image. So what we do, we pass the image through CNN, and the fully connected layer, which is the seventh layer, which is before the output. So there we have got the abstract information about the image. Now we feed this as the S0 in the RNN. So this is the RNN.
Okay.
And for example, this image, for example, was a road and a hill. So this fully connected layer 7, which is there in CNN, it obtains all the abstract information which is available in this image. And if we train it, for example, I know that, for example, that there is a river along the hill. For example, this is my training. So what I will do, S0, I will feed this. Here will be go, last will be stop, and then I will train. So in this parameters, what will be the parameters? Parameters will be W, V, U, B, C. This is for the decoder, and we know for the CNN parameters. Those parameters which are available. So we pass it. So this encodes the information and this decodes. So now when we took another example of machine translation, if we take the same example, so we will have RNN in both encoder also and decoder also. So I'll cover it again. So for this machine translation, input is मैं घर जा रहा हूँ and output is I am going home. In a classical encoder decoder, what will happen? We will feed this मैं घर जा रहा हूँ. This we feed to RNN. This is the RNN. We pass it to 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 RNN. And this last part which is there, for example, if I call at as, for example, H5 in this case, so this is H1, H2, H3, H4. This is input X1, X2, X3, X4, X5. So only this part is fed to the decoder. And what there is an alternative way also. What do? We take another part and it will take, for example, it will start from go. So this becomes S0. This gives output. So output should be I. Now it goes to second. This I becomes feed here. Should give am. Now here comes am. It should come going. Now going goes to should give home. And here I give home. And here it should become stop. Stop is the last one. So another way is that I take another input from here and I feed to all the RNN layers. So I'm feeding as a S0 also and to all layers also. So here is S1, S2, S3, S4, S5. So this is a classical encoder and decoder. This is the decoder and this is the encoder. So this was covered in the encoder decoder lecture. Now we are coming to why do we require attention mechanism. So in the encoder decoder, do we have any problem of understanding? Anyone? If there is a task of video captioning, what we will do? What will be the framework for encoder and decoder? Abir, any help again in this?
Yeah. If
Will give the take the output, like the encoder will be a CNN. It will give information, and the decoder will be RNN, which will summarize what is happening in the video. Maybe.
Okay. So I will cover here only. You can go through the lecture again, okay? Just the brief part. Video is nothing but it is a collection of images. Images, we pass it to the CNN. We pass it to the CNN. And this output from the CNN, we feed it to the RNN.
Understood.
Okay. This is fed to the RNN. And this RNN video captioning, for example, we know that only there are finite words only. Finite words.
Yes.
Okay. Then the output of this, so this is known as RNN of CNN. Okay. And output of this we feed to the forward neural network. So this will give us the captioning. So we keep on training over that. Okay. So now coming back to the problems, what we foresee and what is the motivation. I will erase this RNN and CNN part. Okay, I will come down. Okay. So the motivation for here, that why do we need attention mechanism? Now there are, first of all, one need is that we are using H5 And we know that this H5 contains all the abstract information of H1 to H4, and we are using only H5 as the input as S0 and to various other layers. But if we see the machine translation, here was मैं घर जा रहा हूँ. Now, if we see the first I is related to which? I is related to मैं. Similarly, am is related to what? It is related to whom? Ghar, ghar is related to home is related to three. I am going is related to जा रहा हूँ, both these parts. So first motivation is that instead of feeding H5 to everywhere, we know that I gets more affected by here X0, for example X1, sorry. M is getting from I am means X5. Similarly, going is getting related to, it is getting more context from X3 and X4, and home is getting from X2. So instead of using only H5, why not to use at every layer the weighted sum of this H? So I know that here when I will feed, I will get more information from H1. When I go to N, I will get more weights of X5. Similarly, when I go to S3, I will get from X2, X3 and X4. And when I go to this step, then I get more information from Ghar. Is this clear? This understanding?
Yes.
Okay. And in the same way, the humans also we do the in the same way. So how to achieve this? So now to achieve this, what we can do, okay. So what we can do that this is H1. I'm not drawing full. H1, H2, H3, H4, H5. So at every step, what I said that I have to take the weighted sums of this. So let's call this as Cj, for example. So for first step, Cj will be different. For second step, Cj will be different. For third step, Cj will be different. And this Cj which is there, this is, we say that this is alpha Jt. Okay, for example, this is alpha H1, and for the first step, it will become alpha 11, alpha 21, alpha 31, alpha 41, and alpha 51. This is for the first step when we feed it to the first step of the encoder. So for the first step, I know that the most important part was, for example, I. So here, this is I. So here alpha will become more and they will be minimized. So they are less. So here in this step, to the encoder, I'm getting more information from I. So this is the intuition. Now how to calculate this Cj and how to calculate it, this alpha, for example, Ij, or I say Jt, where J is the input word which is affecting more with more information, and T is the time step of the decoder. So how do we do achieve this alpha, and from alpha only this Cj will come. Cj we know, Cj is nothing but weighted average of alpha Jt into Hj. So whichever H is there, it will give more voltage to this. So this is clear Cj part?
Yes.
Okay. So how to achieve alpha Jt? So see, This alpha JT depends. I will introduce something called EJT. EJT is the information, it is a scalar. Now, when we are in a decoder, we are going from this step to this step to this step. So, for example, if we are at this step, for example, at present, T, J is the jth word in the input, T is the time step, and I say that this is the value which is affecting this at time step. So this will be a function of some function of, this is also carrying the previous value. So here is st minus 1. So it will be some function of st minus 1 and some function of hj. Is this clear? We are just saying that EJT is a value, how jth word in the input. Just give me 30 seconds. My dog is barking. Okay? Hello, Abhi. Can you hear me?
Yes. Loud and clear.
Okay. So I say that EJT is the value which defines that how jth word in the input is affecting the output at tth time step at decoder. And this is some function of st minus 1 in the decoder because it is carrying some information from the back, and also the word in the input. Is this correct? That it can be a function of st minus 1 and hj?
Yes.
Okay. So as a concept, okay, we say that this EJT is nothing. It is a score. I will cover the score later on. st minus 1 and hj. And if we calculate this EJT, now this EJT will be different for this, 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 will be different for this. Is this clear that this EJT will be different for the edges? Hello?
Yes, it is clear.
Hello? Okay. So
Hello.
we say that, hello, yes. Okay. So this is a EJT is nothing but a score, and this will be different for all this. So for example, at tth function, at tth time step of decoder, for example, here is I am मैं घर जा रहा हूँ. So at time step 2, where I'm getting output as am, this who will get the maximum. So from this EJTs, which are EJTs I have got for all the input words, I calculated alpha. Alpha JT is nothing but the soft max of EJT. So here alpha, wherever this EJT is maximum, the alpha will be maximum. So for example, I can say at time step this is 0.8, 0.05, 0.05, this is 0.05, and this is 0.05. Is this correct? So I will get now from here alpha values. So here alpha values I've got 0.8, 0.05, 0.05, 0.05, 0.05. And when I feed it at time step this, so Cj will become this alpha Jt into Hj. So maximum input will go from Hj. So in this case, it will go from whom? When the decoder is decoding M. Is this clear? I'll cover it again,
Yes.
all the steps. I'm just covering for the basically understanding part, that how it is happening. And now when I have calculated this Cj, now when I go to the decoder RNN, so at decoder RNN, what happens? Along with the this xt which I was feeding, I am feeding st minus 1, and I am feeding, for example, here the previous word which was coming. So along with that, I feed the Cj. So decoder RNN, st will become RNN of st minus 1 and y hat t minus 1, because here the input which comes, this y hat becomes the input for the next step. So this is y hat t minus 1. And along with this, I am feeding Cj and Cj. Or we can call it Ct, sorry, for the time step Ct. So this how this st is calculated, and then output okay, we use okay, v into softmax of v into st plus bias of the v. So this is clear. So this is how your attention mechanism, what we are doing. So I will revise it again. In a classical encoder decoder, I was just using H file and I was feeding into all the layers. But we realized from the how humans translate, we know that some words in the encoder, they get affected by some words in the encoder. So why not to pay more attention? The word attention has come from there only. Why not to pay more attention to those words? So how to pay the attentions? Then we defined that we should have some quantity called alphas, and alpha will denote that how much attention we are giving. From those alphas, we multiply by the hj's and we calculate the value ct. So ct at every time step will be different, and it will have the attention coming from that input word. So I will cover again all the steps in the attention mechanism. How do we do that? So step 1, we calculated EJT is equal to sum score of ST minus 1 and HJ. Now this score function can be V attention transpose into 10 of H, W attention into ST minus 1 plus U attention into Hj, because we know that it is of some function, and when we do this calculation, if the Hj dimension is, for example, in this case it was 5 into 1, the U can be, for example, 5 into 5. So this will give us 5 into 1 vector. Similarly, for example, here in this case, st minus 1 which is there, I say it is also 5 vector, but in this case it is 4. So if it is 4, then we change the dimensions of W attention. If it is 4 into 1, then we will make it as 4 into 5. This will become 4 into 5, and 10H of this will get 4 into 1 vector. And we multiply by this V attention. V attention is also 4 into 1. When we do transpose, it becomes 1 into 4. And 1 into 4 into 4 into 1, we get one value, which is a scalar value. So EJT is for every this is a scalar. Now step 2, we calculate alpha. Alpha JT is nothing but softmax of EJT. So for 4 HJs at one time step, we'll get 4 alpha values, 1, 2, 3, 4, 5. And this alpha value is denoting the importance of that input word. Step 3. Now from this alpha, we calculate CT. This is summation alpha JT into HJ. J is equal to 1 to N, whereas N is number of input words. This is clear. Then we come to step 4. At step 4, in decoder, we calculated ST is equal to RNN of ST minus 1 and Y hat T minus 1 and CT. We concatenate that, we pass it to the RNN, and we get this. Step 5, we get Y hat T is equal to softmax of V into ST plus V. So is this clear? Okay, this understanding, all the 5 steps. Does anyone?
Step one is still a little vague, but if we go to an example, I think it will be much clearer.
Okay, so it is looking vague because we are saying that we want to have some value which denotes the importance of the HJ word which is coming, and at the
Yes.
ST step. Now at
Yes.
the ST step, we know that at ST, for example, I will use some other. We take encoder, for example, here. So here is the ST, for example. So at ST step, it gets affected by ST minus 1,
Yeah.
and it is getting this word which is coming, it is coming from Y hat T
Yes.
minus 1. And along with this, we want to feed this information CT, which contains the information from the input word. That this at this time step, this input word is more important.
Okay.
Okay. And how we are calculating? We are calculating by a score function. Now, score, one of the score function can be this, which I have written and which
Okay.
has been covered in the lecture. And I have also demonstrated that this is a scalar value.
Yes.
So for all the HJs, we will have different. For example, in this case, we had H1, H2, H3, H4, H5. And for example, step is 2. And we know that at step 2, M is more important. So M is मैं घर जा रहा हूँ. So it should become 0.5 and it should become 0.5 alpha values.
Yes.
So from here, each AT which will come, so these are the tunable parameters, V, W,
Okay.
and U.
Okay.
So when we do BPTT, they get tuned. Now we calculated alpha as softmax, so we will get 5 alphas. We multiply them with HJs and we get the CT.
Yes.
And this CT we will feed to the apna decoder part. So this concept is clear.
Yes, it
How
is.
it is working? Okay, okay, very nice. Because this concept will help us. Okay, tomorrow I'll cover transformers. Okay, so
Okay.
from here, should we move to LSTM now?
Sure.
Yeah. Anyone any doubt on this
Can you
regarding
please do 4 and 5 again?
4 and 5? Okay, okay. So EJT is clear. From EJT we got alpha JT, we got CT. Now at step 4, this is the decoder. He's getting information from ST minus 1, and it's during inference. This was Y hat T minus 1. It gets input into this. Now along with this, I gave the input CT also, just to give information that at this time step, this word from the input is more important. CT is containing that information basically. We concatenate this Y hat T minus 1 and this both. We concatenate and utilize this information. So I'm using Y hat T minus 1, CT, and ST minus 1 to calculate ST. And to calculate with Y hat, we pass it to V and we utilize softmax function to get Y hat. Is this clear?
Yeah.
Okay.
Thank you.
So this is the basic concept. If you remember these 5 steps, so your attention mechanism is over here. The question will come again. In this, they cannot ask in the calculation because calculations are heavy. So they can ask a question regarding the concept only. Okay, so CT is the one which is gathering the information and it is containing the information that at this time step, this HJs are more important. Instead of H5, which we were doing earlier, H5 we were feeding to all the layers. Now we are feeding selectively. Okay. Now we go to LSTM method.
Yes.
Okay. Okay. So LSTM, I will cover the basics first. Okay. Okay. So in the classical RNN, what was one of the problem? One problem was diminishing gradients, because when the loss were flowing, it was become W tau. So if W was, for example, very less, for example, 0.1, then at every time step, it was decreasing. And another was exploding gradient. If W is equal to 10, then so we know that exploding gradient can be controlled. If we make the W value, for example, less than 1, then exploding gradient we can control. But then how to control the diminishing gradient? So one of the solution is LSTM. Basically, we have got forget.
How exploding gradient can be controlled by using adjusting the W values.
W, when initially we make one W initial. So initial, when you initialize, you always initialize less than 1.
Okay.
So they will not explode and then they get tuned. Okay. Now I'll cover one diagram for understanding of this, and you can please note down in your notebooks also. It is very, very helpful. Then the whole LSTM understanding comes. This is in LSTM, we carry two values, ST minus 1 and we carry HT minus 1. Okay. This HT minus 1 which is there, this ST minus 1 which is there, I have covered here also. So then on my jam board I'll cover it. Okay, this is the diagram. So ST minus 1 is coming from previous layer, HT minus 1 is coming from previous layer, XT we are giving from down input. So this is the at time step ST. If you can see my mouse hovering. So here at T we are getting XT. So first we say that I want to forget which is coming from backside, for example. So the first gate which we utilize is the FT gate. Now this is the output which we get FT. So if we see this diagram, what will be the FT? FT is equal to, this is 10H of HT minus 1 into W of F forget gate plus we are getting input from XT also, XT into UF, and there is a bias of this forget gate. So this output we get. So this how we can control that what is the information which is coming from back, and I can forget that information. So this FT is clear, forget gate.
Clear.
Okay. The next gate is input gate. So this FT controls input from ht minus 1. I want to forget. Okay. The second gate is here. Here from here we get IT. This is the input gate. So input gate also, if we see, is equal to 10 of W. Sorry, I have written here after. It should be written I. Wi ht minus 1 plus ui xt plus b of I. So here I get I. This controls the input, controlling the input, whether I want to read or xt or not. So this is controlling the xt part. Now here, this I take, I multiply here. This I will cover later. Now here again there's another one gate which I utilize as a normal for a S tilde. S tilde t is nothing but 10 of normal W of RNN into ht minus 1 plus normal U of RNN xt plus bias of RNN. So I get S tilde. So if we see these diagrams, they become very clear that how we are getting the information. We make tildes and all that. And now we utilize IT into this. IT which is there, we feed it and we multiply this.
Can you please repeat what was ST?
Yeah, I'll cover. And here we add. So this we get as ST. Here we pass it to tilde. Here is a output OT. We do drop of this. We get HT minus 1. Just let me make the diagram first, okay?
Yeah.
Yeah. So this is X HT. Yeah. Okay. So see this diagram. From the previous step, we are getting this is coming from the previous time step st minus 1 and ht minus 1. When it is coming, I apply the gate. First gate is the forget gate, in which I want to forget whether I have to take input from ht minus 1 or not. xt is the input which is coming from down. So ft, we can see ft is nothing 10 of w of f into ht minus 1 plus u of f into xt plus bias of this forget. So this is clear forget part.
Yeah.
Now I come to input. Here I want to control whether I want to read xt or not, how much I want to read. So here I put wi into ht minus 1, ui into xt plus bias of I. So this is controlling the input. Then I take this ft, I multiply by st minus 1. So here I get a value. This input, here I control a normal RNN S tilde. I calculate normal RNN S tilde, which is nothing but 10 of WHT minus 1 UXT plus B. So see, these terms, okay, we have to remember in LSTM, they will come everywhere. HT minus 1, XT, XT, HT minus 1, XT. Now we pass this S tilde and IT, we take the dot product of this. So we get the output from here. Similarly, this forget gate, which I have obtained here, ft, I multiply by this ft minus 1. So st will become, this is st, st is equal to ft dot st minus 1 Plus.
basically, what's ST?
Yeah, plus.
मतलब ST.
Plus,
What's
your voice
ST
is
in
not
this?
coming.
Hello.
How less?
मैंने कहा what's मतलब ST क्या है इसमें basically LSTM में?
ST is the output for the second, and this ST we are utilizing at this layer for Y hat.
ठीक है.
Okay, this is Y hat is nothing but softmax of V into ST plus B, and this ST we take to the next time step also.
तो ये आउटपुट गेट से पास नहीं होगा ST?
या नहीं, ST पास नहीं होता, HT होता है.
ठीक
है.
है.
I will come to the output gate also. ST does not pass, only HT passes. So
Okay.
ST is equal to FT dot के this. यहाँ पर वैल्यू क्या आ जाएगी हमारी? यहाँ पर आ जाएगी IT dot S tilde. इसको हम पास करते हैं तो from here diagram we can understand, here we get ST. Okay. Now जो last में है, input we have understood, forget we have understood. So forget is basically to control how much we want to read from the previous state, that is from HT minus 1. Input we want to control how much we read from the XT. Okay, we do the dot product, we add this, we get the ST. So ST straight away goes to the ST, and ST we utilize to calculate the Y hat. Now we also want to control how much output it should go in the HT part. So what do we do? Again, we take this. Here there is a 10. So here this OT will become again 10 W of O HT minus 1 plus U of O HT plus bias of O. This is the output. And now for the next time step, HT is nothing but OT dot product 10 of ST. So we have got ST and we have got HT, and we have understood that here we are trying to forget from HT minus 1. Here we are trying to selective read from XT. We calculated S tilde, utilize IT dot product S tilde. So this X is dot product everywhere, and plus is plus. So if we remember this diagram, then our concept becomes very, very clear. Or does anyone want me to cover it again?
Yes, sir. Run through it just one last time. Just quickly.
Okay. So what I will do, I will make this diagram again, है ना? For
Okay,
understanding. ST minus 1, HT minus 1. Here comes XT. I utilize, this is the forget. I get here forget. I take this to the dot product. I utilize second 10H. I get here IT. Then I come here. I take S tilde by normal RNN. I do the dot product of both and add this and this. I get ST. Okay. Here now again I make one output OT. Feed this ST via 10 to the dot product and add I get HT. So now here we can write all the formulas clearly if you remember this diagram. Does anyone have this here? Shall I write again? FT is equal to 10H of WF HT minus 1 plus U of F XT plus B of F. IT is equal to sigma W of I HT minus 1 plus U of I XT plus B of I. Then I calculate S tilde. S tilde is nothing but normal plus UHT plus B. Then I get ST is equal to FT dot product ST minus 1 plus IT dot product S tilde T. HT is equal to, okay, OT ka bhi I have not written, we can write for OT also, and this will become OT dot product sigma of ST. So these are the formulas. Is this clear with everyone now? Ullas, clear?
Yes, it is clear, sir.
Yes, sir. Yeah.
Yeah. So with this diagram, the things become okay, slightly easier to understand. Okay.
Sir, you have not written the formula for OT.
OT is the same again, like I have mentioned here, same formula.
Okay.
This HT minus 1 and UOXT plus B of O will remain. So come in all for OT, S tilde, everywhere this will come. So remembering part becomes easier. And just when we see this diagram, we can calculate ST. ST is here. So ST is summation of this dot product and this dot product. And this utilize, now we want to carry forward information in HT selective. So we utilize 10 of this, OT dot product of this, and we carry HT. Okay. So GRU here only briefly I will cover here that GRUs, they don't have 3 gates, they have got only 2 gates. And GRU picture is here. It has got only input gate and output gate. So this diagram, okay, you can just see it, instead of forget gate in the last, it uses 1 minus IT as the forget.
Understood.
So now conceptually one question can be asked in this, that how LSTM solves diminishing gradients problem. Just they will ask, okay, for example, first of all, LSTM does not solve exploding gradient. Okay. But again, that can be solved, we have seen, by making W's less than 1.
1.
Okay.
That's the
It only solve diminishing gradient. And how does it control? It says that if some ST minus 1, for example, in the RNN, so see what is happening, how the RNN will become like this. So these gates are here. So this is the RNN now. HT minus 1, HT minus 1. This is ST. We utilize this ST for Y hat. Take HT, ST plus 1, HT plus 1, and here ST plus 2, HT plus 2. So it says that here when we apply the gates, so we are forgetting, if the HT minus 1 is not important, I forget by the forget gate. So when it was not important, so the gradient loss which was flowing in earlier RNN throughout, it was running throughout and it was diminishing. Here it diminishes only where it has to diminish, because now it will pass through these gates also. So just understand, okay, this concept only. I will not go into the mathematics. So basically, if the LSTM gradient vanishes where it must vanish. Okay, it does not vanish because gradient flows through the gates. So if some gate we didn't pass the information that did not contribute, so while flowing back also it will diminish, and it must diminish here. Okay, so that is the concept right there. So I think
So,
for
Lalit,
today
what's
these
the
two.
difference between?
Hello.
Ask one question. Hello.
Yeah, please. Okay, but your
Hello.
voice is not audible. Actually, I'm having internet problem slightly at my home.
So basically, what's the difference between LSTM and GRU?
GRU. Okay. So in GRU, we don't have FT. We use
Forget it, नहीं होता.
1 minus IT. We have got to take care to forget.
Okay. Now it's
Okay.
clear.
Yeah. So this is
Thank you.
if you can see my screen here, this is the GRU. So here it is using 1 minus IT as a forget.
Okay.
So I think for today, this two concepts, okay, can we call it off here?
Sure, sir.
Or do you want me to cover something else
No,
also?
no, no. It's
Okay,
okay.
we will solve this
tomorrow
question. Somebody had posted this, so can we solve this question? Okay?
Sure.
Is my screen visible? Okay, this question, if you can try it out.
Yes. You can.
So all of us, can we try this question? Is the question visible to everyone?
Yes, it's visible.
Okay. So basically, we have to calculate. This is the loss function. Output is using sigmoid. Actual y is this. H3 is this. A4 is this. Y hat will become sigmoid of A4 is equal to sigmoid of 1 0 minus 1. This will come 0.5. This will become 0.73. This will become 0.27. So this is y hat. Now we know that we have to calculate dl by dw. dl by dw is dl by da4 into da4 by dw. Now when we do the da4, लॉस की वैल्यू है हाफ y hat minus y k स्क्वायर. सो पहले इस da4 को हम क्या dy hat लिख लेते हैं और dy hat ओवर da4 कर लेते हैं, है ना?
Half outside the square.
हाँ जी,
हाफ स्क्वायर के बाहर होगा.
यस यहाँ पर. So dl by dy hat is equal to, this becomes sigmoid का y minus y hat into 1 minus y hat. Is this correct? Okay?
Yes. But if you're doing for W,
Yeah.
then if you're doing for W, then there should be another term, right? No?
No. Okay. So I will do again. dl by dw is equal to dl by dy hat over dA4 over dA4 over dw. Is this clear?
Yes.
Okay. Now we say, for example, loss is, so पहले ये वाला निकाल लेते हैं, ये तो स्ट्रेट निकल जाएगा, this will become h3. एंड हमने एक बार प्रोफेसर ने हमको ये कवर करके दिखाया था कि ये वाला जब हम करते हैं तो हमारा आंसर है क्या, y माइनस वाई हैट इंटू वाई हैट इंटू 1 माइनस वाई हैट आता है. उल्लास जरा चेक करोगे y माइनस वाई हैट है या y हैट माइनस वाई है?
एक मिनट, ये बेसिकली fx माइनस वाई.
ओके, fx माइनस वाई है तो y हैट माइनस वाई हो जाएगा.
हाँ,
तो
एक
अब
मिनट
देखो,
दोबारा check कर.
ओके, सो y हैट हमारा निकला है 0.73, 0.5, 0.27 minus y is 001 into
Let's check
0.73.
check करने दो एक बार.
हाँ जी,
मैंने कहा चेक करने दो एक बार फॉर्मूला.
हाँ हाँ कर लीजिए.
y hat minus y.
ओके, तो ये हो जाएगा 0.73 into 0.73 into 0.27 और ये हो जाएगा 0.5 into 0.5 into 0.5, 0.27 to 0.27 into 0.73 is equal to 0.125.
ये अपने बेसिकली W निकाल रहे हैं.
नहीं नहीं, डब्ल्यू नहीं, ये अपनी ये वाला निकल रहा है. अभी तो ये वाला वैल्यू निकल जाएगी ना dl by dw, और इसको ये वाला पार्ट, ओनली दिस पार्ट, ये तो स्ट्रेट अवे h3 है. तो ये हो गया 0.05, इसका डायमेंशन हो गया 3 into 1, 3 into 3, और h3 जो है अब हो जाएगा हमारा, h3 से इसको मल्टीप्लाई करेंगे 1 1 minus 1 1, ये हो जाएगा 1 into 4. So we will get a 3 into 4. इसको करते थे हम H3 ट्रांसपोज 4 into 1 को, इससे हो जाएगा, इसको ट्रांसपोज कर लेंगे तो फर्स्ट वैल्यू हमारी क्या आएगी, 3 into 1 into 4.
ऐसा करो ना, कुछ एप्स बंद कर दो जो काम के नहीं आ रहे थे.
हाँ, 0.14
ओवरलोड
0.14 minus 0.14 0.14 0.125 0.125 minus 0.125 0.125 0.05 0.05 minus 0.05 minus 0.05. ये है अपना जो, ये डेल्टा डब्ल्यू आ जाएगा. इसके सम एलिमेंट से करके देख लें इसका. हेलो, एम आई ऑडिबल?
Yes, yes, audible.
ओके, ये मेरा वन नोट पुराना है तो ये हो जाएगा 0.28 ये हो जाएगा 0.125 0.125 0.25, एक तो कट जाएगा एंड ये हो जाएगा 0.1। 0.63 था। somebody had posted this क्या? Can somebody check whether this is the correct
नहीं
answer?
0.24 है आंसर, 0.24
0.24।
हम्म,
So
जो वो निकाला है ना आपने, क्या बोलते हैं उसको,
कौन सा?
डेरिवेटिव, वो
हाँ
करो।
हाँ,
तो जो
ये देखो।
डेल एल बाय डेल वाई है, हाँ जो डेल एल बाय डेल वाई है वो वाई के माइनस वाई लिख दिया अपन ने, ठीक है। लेकिन जो डेल वाई बाय डेल ए फोर है ना, वो
हाँ
हम उस
हाँ
इक्वेशन से निकालेंगे, सिग्मोइड वाली इक्वेशन से। क्या होता है, y इज इक्वल टू क्या होता है, सिग्मोइड ऑफ ए फोर होता है। तो सिग्मोइड का
हाँ।
डेरिवेशन आएगा वहाँ पर, वहाँ सिग्मा वन माइनस सिग्मा आएगा, जहाँ पर आपने वाई केप वन माइनस वाई केप लिखा हुआ है।
ओके, तो फिर से कर लेते हैं इसको, है ना?
हाँ, मेरा मेन डाउट ये था जो
हम्म
मैंने पूछा था उसमें, कि जब ये फर्स्ट वाला टर्म निकाल रहे हैं डेल एल बाय डेल वाई केप, राइट,
हम्म
इसमें क्या है, लॉस फंक्शन क्या है अपना, हाफ सिग्मोइड ऑफ वाई केप माइनस वाई, वो समेशन हो
हम्म
रहा है। तो जब
हम्म।
हम y के माइनस वाई निकालेंगे तो ये वेक्टर आ रहा है 0.73 0.5 0.27, राइट।
हाँ, तो इसका इसका
तो
क्या है
वहाँ पे
एट?
समेशन, वहाँ समेशन था, तो इन तीनों को क्लब करूंगा मैं या फिर इन तीनों को अलग अलग रखना है, वो चीज में
नहीं,
कंफ्यूज हो
इसको
रहा था।
क्या करेंगे? सो जस्ट सेकंड, फिर से इसको कर लेते हैं, एक मिनट।
सो जब हम डेरिवेटिव निकालते हैं तो समेशन हटा देते हैं।
नहीं, समेशन क्या है कि जो आपका जो डेरिवेटिव निकलेगा वो वेक्टर निकलेगा।
अच्छा,
जो आपका डेरिवेटिव यहाँ पे निकलेगा, सो आपने क्या किया है?
देखो
मैं इस पे कवर कर लेता हूँ, जैम बोर्ड पे। जैम बोर्ड ज्यादा ठीक है। ये जैम बोर्ड, ये विजिबल है जैम बोर्ड?
यस,
Okay. So delta L by delta W is equal to delta L by delta Y hat, delta Y hat by delta A4 by delta A4 by delta W। डेल्टा L by डेल्टा Y hat निकालेंगे तो ये स्ट्रेट अवे आपका हो जाएगा Y hat माइनस Y, बिकॉज लॉस इज इक्वल टू हाफ इंटू Y hat माइनस Y का स्क्वायर। तो डेल्टा L by डेल्टा Y hat is equal to 2 into 1 by 2 into Y hat minus Y into 1 is equal to Y hat minus Y। ये हो गया, ये वाला पार्ट आ गया। Now Y hat is equal to sigmoid of A4। So delta Y hat sigmoid का क्या होता है?
सिग्मा वन माइनस सिग्मा हो जाएगा इसका।
सॉरी, ये था
A4 minus A4।
ओहो ओहो, कम, ठीक है ठीक है ठीक है। ये सिग्मॉइड था ना मेरे आपके क्वेश्चन में? तो
तो सिग्मा वन माइनस सिग्मा हो जाएगा इसका।
ये वाला जो पूरा पार्ट है, इसका जो डेरिवेटिव लेते हैं वो y hat माइनस y होता है। लॉस जो, अरे यार, लेकिन एक मिनट, तुम्हारा क्वेश्चन देखते हैं फिर
वो
से।
तो
अगर
सब नेक्स्ट
सिग्मॉइड
होता
है,
था ना।
अच्छा ये बताओ सिग्मॉइड का डेरिवेटिव क्या होता है?
सिग्मा वन माइनस सिग्मा, दिस इज द
सिग्मा
डेरिवेटिव ऑफ
नहीं,
सिग्मा।
1
A4
वही
fx
तो
और
बोल रहा
1 minus fx, ये मान लो।
हूँ, एफएक्स कहाँ से आएगा यहाँ, नहीं, सिग्मोइड वन माइनस सिग्मोइड।
हाँ,
ओके ओके।
sigmoid then 1 minus sigmoid।
सिग्मोइड टाइम्स
हम
1
सिग्मोइड का ही तो डेरिवेशन निकाल रहे हैं सिर्फ, और क्या कर रहे हैं, सिग्मोइड का डेरिवेशन निकाल रहे हैं ए4 के रिस्पेक्ट में, और ए4 अंदर है सिग्मोइड के, सिग्मोइड आ जाएगा सिग्मोइड वन माइनस सिग्मोइड,
ओके,
और उस सिग्मोइड में ए4 डाल के निकाल लेंगे वैल्यूज।
तो ये हो जाएगा सिग्मॉइड ऑफ A4 इनटू 1
वन
माइनस
माइनस
and
सिग्मॉइड
1
ऑफ A4।
minus sigmoid of A4।
राइट।
ये हो गया ना? तो हमने
बस
कैलकुलेशन तो
अभी
ठीक
सब
किया था।
मल्टीप्लाई करना है।
तो ये y
ये तो
hat
पहले
0.73
ये
0.5
पहले नहीं लिखा था, पहले y था।
y hat माइनस y था 001, ये वाला पार्ट आ गया, ये वाला। और ये हो जाएगा सिग्मॉइड ऑफ A4। सिग्मॉइड ऑफ A4 इज नथिंग बट यही है 0.73 0.5 0.27 into 1 minus 0.73 1 minus, ओके यहाँ पे गलती की थी हमने, ये जो, लेकिन यहाँ पे भी ठीक था, 1 minus 0.27, ये जो है अब ये हो जाएगा 0.73 0.5 0.27 into 0.73 0.5 0.27 into
ये 0.27
0.27
-1 होगा ना, तो नेगेटिव वैल्यू नहीं आना चाहिए।
सर माइनस
y माइनस y में y
हाँ।
हेड माइनस y में,
ओके
तो
ओके ओके,
माइनस
0.27 माइनस 1 है,
वहाँ पे गलती
0.27
करी थी हमने
बस।
पहले।
यहाँ पे गलती की थी हमने, तो ये हो जाएगा
हाँ।
माइनस 0.73
हम्म।
माइनस 0.73 है ना, ये 0.27 है और ये हमारा ठीक है 0.73, इसको मल्टीप्लाई करते हैं तो ठीक आना चाहिए हमारा, ये 0.14 0.125 और ये जगह माइनस 0.14, और इसको हमें मल्टीप्लाई करना है अपना किससे, H3 से, H3 के ट्रांसपोज से, H3 क्या था, 1 1 minus 1 1 1 1 minus 1 1 1 1 minus 1 1, so we will get here 0.14 0.14 minus 0.14 0.14 0.125 ऐड करेंगे तो ये कैंसिल हो जाएगा, ये कैंसिल हो जाएगा, ये माइनस 0.14 और माइनस 0.4 कवर कैंसिल हो जाएगा, ये कैंसिल हो जाएगा, ये कैंसिल हो जाएगा, 0.25 आता है आंसर।
सही है।
अब ठीक है, है ना, ठीक है, तो ये सॉल्व हो गया। और बताओ, एनी अदर क्वेश्चन?
वो था ना अपना 3D वाला, 3D टावर वाला, वो आपको आ गया, मतलब आप कह रहे थे
3D
कि
टावर
मतलब
दोस्त मैंने टच नहीं किया अभी। टुडे आई विल डू ट्रांसफॉर्मर्स एंड आई विल डू रिवीजन, क्या ये जब मैं अपने आरएमएस प्रॉप क्या रेगुलेशन।
और एक क्वेश्चन और था जो,
हाँ बताओ।
एक क्वेश्चन और था जब हम व्हाट्सएप, वो मुझे नहीं पता कौन सा पेपर था, लेकिन वो
Okay.
जिसमें हम 2D वाला क्वेश्चन देखा था हमने सबसे पहले जिस पेपर में, उसी पेपर में एक और क्वेश्चन था जो इससे रिलेटेड था, आरएनएन से, आरएनएन का डेरिवेटिव से, तो वो हमने करा नहीं था, स्किप कर दिया था वो वाला।
नहीं, आरएनएन का डेरिवेटिव तो हमारा क्लियर है, बताओ कौन सा करना है।
कल किया थे हम सुबह,
कल पूरा बीपीटीटी हमने किया कल।
हाँ करा तो था कल वाले में, कवर हो गया।
कल वाली रिकॉर्डिंग में देखोगे ना कैसे वो लॉस फ्लो कैसे करता है, ये एक लॉस यहाँ से आ रहा,
ठीक है, ठीक है।
एक लॉस यहाँ से आया था, है ना, यहाँ पे एस था फॉर एग्जांपल, S3 है,
वो था अच्छा जो कल पढ़ा था, उसको एक और बार देखना पड़ेगा पूरी वीडियो।
हाँ,
ये वाला पार्ट इम्पोर्टेंट
ये
था।
वाला पार्ट है,
तो कल
ये हो जाएगा।
हम जो कल जनवरी का पेपर कर रहे थे उसका लास्ट 2 क्वेश्चंस नहीं किए थे ना?
जनवरी का कहना तो मेरे नेट की प्रॉब्लम है,
मैं लिंक सेंड करता हूँ, रुको।
ओके, नहीं मैं खोल रहा हूँ, मेरे नेट की थोड़ी सी प्रॉब्लम चल रही है। ये जनवरी वाला, ये वाला क्वेश्चन,
हाँ
ओके, लेट मी ओपन।
वो तो वर्ड वोकैब बनाना था ना,
वर्ड वोकैब का था वो क्वेश्चन,
इसलिए हाँ वो छोड़ दिया था। उसमें लास्ट वाले क्वेश्चन में कोएक्रेंस मैट्रिक्स का डायमेंशंस पूछा था, क्या क्या हो सकता है, वहाँ पे मुझे पूछना था 14 क्रॉस 14 तो समझ में आ गया, देन कोएक्रेंस में 14
हमने
क्रॉस 13 एंड 14
वो नेजी ईपॉक वाले क्वेश्चन तक किया था, जहाँ
ओके,
2
लेट्स सी द
बार
लास्ट क्वेश्चन।
वो कम इसलिए होगा शायद क्योंकि हम जो क्या बोलते हैं, कौन से वर्ड्स बोलते हैं उन्हें, जिन्हें हम लीव कर देते हैं
ये
पूरे सेट में।
16,000 वाले क्वेश्चन
स्टॉप
तक
वर्ड्स।
किया था।
ओके
स्ट्रोफ वर्ड्स, तो स्ट्रोफ वर्ड्स की वजह से शायद इस वजह से कम हो सकता है कोकरेंस मैट्रिक्स, ये हो सकता है लॉजिक।
ये क्वेश्चन था ये वाला,
इसी की बात
इसके ऊपर वाला
यहाँ से स्टार्ट होता है ये।
नहीं, एक ये वाला, ये ट्रू फॉल्स वाला।
हाँ ये तो देखो हमने पढ़ा है ना, कंसीडर द स्टेटमेंट द अटेंशन मैकेनिज्म इन आरएनए बेस्ड एनकोडर डिकोडर आर्किटेक्चर helps the encoder to understand the context of words in a given sentence. So it is true or false?
हेल्प्स टू डिकोडर।
नो, हेल्प्स द डिकोडर होना चाहिए था।
Helps the decoder, है ना, encoder की बजाय decoder है।
डिकोडर होना चाहिए।
या ठीक है, ये क्वेश्चन तो स्ट्रेट है, इसमें आपके यूनिक वर्ड्स निकल आएंगे, वोकैबुलरी बन जाएगी।
हाँ।
इसको करें क्या, करना है?
नहीं, इसके
इसका
नेक्स्ट
जो सेकंड पार्ट जो है, इसका सेकंड पार्ट की कह रही है।
ओके ओके, सेकंड पार्ट आई थिंक सेकंड पार्ट इसी से रिलेटेड है, व्हाट दे आर आस्किंग। कहाँ चला गया?
पेपर चेंज हो गया क्या?
नहीं सेम है। सेकंड पार्ट देयर आस्किंग बिल्ड ए वोकैबुलरी, बना ली हमने, एंटर इट सेट्स 14 आ गया। सपोज वी बिल्ड ए कोअकरेंस मैट्रिक्स ऑफ साइज m into n where each row corresponds to a word in the vocabulary and the columns correspond to the context of the words. Which of the following could be a valid size of the co-occurrence matrix? So इसकी अंडरस्टैंडिंग ये होती है कि आपका जो हम बनाते हैं, फॉर एग्जांपल हमारे 14 वर्ड्स आ गए और हम ये बनाते हैं, तो मैक्सिमम तो 14 into 14 हो जाएगा। हेलो,
यस,
इसके अलावा ये कम भी हो सकता है। सो इट कैन बी 14 into 12 आल्सो, 14 into 10 आल्सो।
वो डिपेंड करता है हम कितने वर्ड्स के कॉन्टेक्स्ट को हम वो सिमिलरिटी वगैरह देखना
Yes.
चाहते हैं।
यस यस। सो इसमें क्या होता है कि ये एक मिनट, हमने फॉर एग्जांपल बनाया, ये बना दिया, नाउ कैन समबडी टेल मी कंटेक्स्ट कहां पर है और वर्ड्स कहां पर है इसमें, अगर हम यूज करते हैं तो?
वर्ड
rows are words and columns are context.
यस
राइट।
ठीक है। तो कंटेक्स्ट हमेशा हम क्या कंट्रोल कर सकते हैं कि वी वांट ओनली दिस, मैक्सिमम तो 14 into 14 हो जाएगा सबका लेना है तो, बाकी वी कैन कंट्रोल, इट कैन बी लेस आल्सो, है ना। सो देखते हैं इसका क्वेश्चन क्या है ये वाला। सो 14 into 13 भी हो सकता है, 14 into 7 भी हो सकता है, 14 into 14 भी हो सकता है, तो स्ट्रेट अवे ये क्लियर है? हेलो,
हाँ, क्लियर।
यस।
या एनी अदर क्वेश्चन है क्या?
हमने सितंबर 2022 का पेपर किया था क्या पहले?
सितंबर 2022 को नहीं किया है उस,
कल किया था हम लोगों ने।
नहीं, कल हम
उसमें से एक दो क्वेश्चंस हैं।
मतलब हम
खोल
लोग
लेते हैं
ने
इसको,
रात
खत्म कर देते हैं, इसको खोल के खत्म कर देते हैं फटाफट, है ना। ओके,
इसमें क्वेश्चन नंबर 68 है।
ये सेम, हेलो, हेलो,
ऑडिबल।
ओके। So first question we did yesterday, similar kind of question, तो ये straight away कर सकते हैं हम.
कंप्लीट हो रहा है.
Let's see the question. Which are the following threshold theta values of MP neuron implements and क्या Boolean function assume that the number of inputs excited to the neuron is 4 and it is only greater. If it would have been greater than equal to, then it would have become 4, but it is greater only than it is 3. So we have to focus on the sign AK which is given. Now let's move to the second question. Suppose that W is restricted to only negative values. Suppose further that we define the steepness of the curve as absolute values of the slope. Select all the correct statements about the function. So हमने W का क्या हमने yesterday we had discussed ना? What happens when the W is negative?
W नेगेटिव होगा तो भी
If W is negative, then instead of this, we will have opposite. Sorry, like this. And as we increase B, this will shift here if B increases. इसमें बस मेरा एक डाउट था because in this also what happens कि if we increase the W or decrease the W, steepness कब होगा, बढ़ेगा?
एब्सोल्यूट वैल्यू पे डिपेंड करेगा वो.
हाँ, so इसमें increasing the value of W decreases. उसमें जब W पॉजिटिव होता था तो increasing the value of W used to increase that steepness. Here if we increase the value of W, it decreases the steepness.
एक बार इसको डेस्मोस पे देखना. एक बार डेस्मोस में देख सकते हो इसको. आई डोंट नो ऐसा होगा.
ओके, यहाँ पर ही देख लेते हैं ना.
W greater than 0 था.
ग्रेटर W इज आल्सो नेगेटिव ना.
नहीं, मैं ये बोल रही हूँ अगर W ग्रेटर 0 होगा और W की वैल्यू बढ़ाएंगे तो स्टीपनेस कम होता है ना.
नहीं नहीं नहीं.
नहीं तो स्टीफनेस
अब इनकी अब W एब्सोल्यूट वैल्यू बढ़ाना W की इन द विद नेगेटिव साइन. इफ यू राइट लाइक 10 तो स्टीफनेस बढ़ रही है. 30 कर दो.
स्टीफनेस बढ़ रही है तो लेकिन W की तो वैल्यू घट रही है ना, -2 हो रहा है.
अच्छा राइट वो भी राइट है.
माइनस है ना, तो जितना भी इसको हम घटाएंगे इतना ही स्टीफनेस बढ़ रही है. इसमें उल्टा हो जाता है. ठीक है.
राइट.
Now we come to here. Suppose that a momentum based gradient descent algorithm is used to train this. The parameter update is this.
ये वही जो हम अभी कर रहे थे उसी का अपर पार्ट है.
अच्छा ओके.
मतलब वो सब क्वेश्चन था जो हमने जस्ट किया था पहले.
ओके ठीक है. तो इसमें क्या क्वेश्चन है कि at any given time step UT3 is a matrix. What is UT3? UT3 is equal to beta U3 minus A3. The parameter update tool for the weight matrix W3. W3 का ये है. हाँ, तो W3 हमेशा मैट्रिक्स ही रहेगी. अगर ये मैट्रिक्स है तो इसका डेरिवेटिव भी अपना मैट्रिक्स रहता है. हेलो.
वही है अंडरस्टूड होगा.
It requires bias correction to avoid bias towards 0. ये क्या क्वेश्चन है? It requires bias correction to avoid bias towards 0.
ये वाला नहीं समझे थे कल हम. कल किया था ये वाला पेपर.
ओके. चलो इसको बात के लिए छोड़ते हैं, है ना. इसको देखते हैं क्या कॉन्सेप्चुअली कोई क्वेश्चन है.
और ये थर्ड ऑप्शन भी है इसके अंदर. एक उसमें भी डाउट था.
The update rule for UT3 is wrong. The second term should have been written as delta W3. इन्होंने क्वेश्चन का पूछ लिया U3 अपना पीछे आ गया. Delta A3 into H2 transpose. Delta A3 के with respect में लिया, ये ठीक है. और इसको H2 से हमने मल्टीप्लाई किया. तो ये तो डेल्टा, ये जो वैल्यू इन्होंने दी है ये डेल्टा W हो गई ना. इफ वी सी दिस पार्ट, ये जो इन्होंने लिखा है यहाँ पर डेल्टा A3 T and 2H2 T ट्रांसपोज, ये भी हमने पुराने क्वेश्चन में निकाला था ना, दिस इज नथिंग बट टेक डेल्टा L बाई डेल्टा W 3, तो ये ठीक है ये वाला, and U3 transpose is equal to beta U3 T minus 1 plus 1 minus beta into डेल्टा W ही होता है, तो ये ठीक है वाला फॉर्मूला, बस इन्होंने एक्सपेंड करके लिखा है इसको।
ऑप्शन गलत है।
The second term should have been written as the update rule for UT3 is wrong. The second term should have been written as delta W3T, लेकिन डेल्टा W3T जो है वो तो सेम है, ये हमारे हिसाब से तो ठीक होना चाहिए दोस्त।
नहीं, शुड भी लिखा है शायद इस वजह से, दोनों से कंप्यूट करके वही वैल्यू आ रहा है।
आई थिंक इट इज, उसमें लिखा हुआ है ना कि इट इज रॉन्ग, रॉन्ग नहीं है, मतलब इट इज जस्ट एन अल्टरनेट वे ऑफ राइटिंग, तो इसलिए वो करेक्ट है।
ओके, अंग्रेज इंग्लिश चेक कर रहे हैं वो हमारी, है ना? So it requires bias correction to avoid bias towards zero. Bias है क्या, इसको भी हम करेंगे, और bias को भी update rule, bias correction to zero. ओके, ये कॉन्सेप्ट क्वेश्चन है, ये चेक करते हैं, है ना, इसको कल कर लेते हैं। ये अभी एडम वगैरह नेडम एंड ऑल दैट आई हैव नॉट रिवाइज्ड है क्या, सो दैट आई एम प्लानिंग मे बी टुमारो, so that I will not be able to do. लेकिन in Adam है ना, MT does not require bias correction. The update rule for Adam is given below. MT is equal to this, VT is equal to this, MT hat is equal to this, VT hat is equal to this. Now you remember here that they have used this formula, and एक अलग वाले क्वेश्चन में इन्होंने अलग लिया था जो हमने कल देखा था,
BT+1 कर दिया था।
हाँ, BT+1, तो या तो यहाँ पर ये गलत लिख रहे हैं या वहां पे ये गलत लिख रहे हैं, है ना? तो हमें तो हमारे जो लेक्चर्स में है, लेक्चर्स में तो ये वाला
लेक्चर्स में तो यही है शायद, हाँ यही वाला है लेक्चर्स में तो,
और ये वाला है, तो इसमें भी क्वेश्चन क्या पूछ रहे हैं, MT does not require bias correction. MT where from the following statements, MT does not require bias correction. VT does not require bias correction. MT and VT are exponential averaging history of gradients. Both beta 1 and beta 2 can take values greater than 1, and in such case the past gradients are given more weightage than the current gradients. लेकिन ये फर्स्ट टू ऑप्शंस क्यों ठीक है भाई, इसमें तो बायस करेक्शन इन्होंने बोला था कि बायस करेक्शन इसमें करनी पड़ती है,
वही ना, यही तो इसके अंदर ये खेला खेल रहे हैं हमारे साथ इंग्लिश का, और कुछ नहीं कर रहे हैं,
है ना? इसमें तो उन्होंने क्लियर बोला था कि भाई एमटी हैट एंड वीटी हैट है क्या, और उसमें
ये बीटा की वैल्यूज पे डिपेंड तो नहीं करता है कि
No,
अगर
no.
बीटा की वैल्यू,
ओनली डिफरेंस ऐसा है, आई टेल यू, ये जो अपडेट्स थे और ये डाटा पॉइंट्स ऐसे हैं, फॉर एग्जांपल इस तरीके से अगर डाटा पॉइंट्स हैं, तो इसमें बस ये था कि अगर हम एम्प्टी हैट को अगर बायस करेक्शन नहीं करते एंड इफ यू यूज एम्प्टी, देन इट स्टार्ट्स फ्रॉम जीरो, एंड देन फर्स्ट अपडेट्स इसके बहुत हाई होते हैं, बट स्टिल क्या द एल्गोरिथम विल कन्वर्ज, ओनली वी डू बायस करेक्शन, वी यूज एम्प्टी हैट सो दैट इट स्टार्ट्स फ्रॉम हियर, यहां से फिर चालू होता है ये। This is
तो शायद उस ऑप्शन में यही बोलना चाह रहे हैं वो कि रिक्वायर्ड नहीं है, इट इज रिकमेंडेड बट नॉट रिक्वायर्ड, वो ही चीज कह रहे हैं,
विदाउट बायस करेक्शन,
यार इंग्लिश में चेक कर रहे हैं।
हाँ, तो बायस करेक्शन हम क्यों करते हैं, ताकि जो इनिशियल अपडेट्स हैं वो नहीं हो, है ना?
राइट,
इसमें इनफैक्ट देयर वाज अ क्वेश्चन इन अर्लियर क्विज़ेस that if you don't do bias correction will it converge? Yes, it will converge, only it affects
Yes.
this region, स्टार्टिंग वाला.
क्विज 1 में था.
Yes. Okay. Now ये this we have covered. Okay, select all the this. ये हमने कवर किया बड़े उसमें कि आपका अगर complexity है, the graph will become like this, and this will become like this. So ये हम clear है वाला. इसमें ये part the price and variance both made zero. The underlying distribution of the samples are known, and all the samples are not corrupted by noise. That ये dropout वाला this question also we have done. If p is equal to 0.75, it means that 75% of the neurons will be selected, not dropped. So for each iteration, 25% will be done, and during inference, okay, we will multiply each weight by 0.75. This is a new question. This we have not done. इसको The figure below represents a Boolean function using a unit output for the function. चलो following guys. Each vertex shows the label or output of the function for the given input. Which of the following is true about the function? Okay. So यहाँ पे क्या है x1, x2, x3 है. So we can write for example x, y, z. इसको x लिख लेते हैं, इसको z लिख लेते हैं. और यहाँ पे है आपकी वैल्यू फॉर एग्जांपल so here x is 0, y is 0, z is 1, and this is 0. For example, this. Now we can put here
हर फंक्शन की एक दो वैल्यू होंगी बुलियन 0 1 0 1 0 1
1 1. Here 1 0 0 0. All 0 this one. Okay, we have forgotten this. 1 1 1 0. So these are the combinations. So the function inputs. The function is not linearly separable. So how it is not linearly separable? Because 1 1 1 is also 0. 0 0 0 is 1. So 1 is here, 1 is here. 0 0 1. So there is no plane okay, which we can draw which can linearly separate them. This is clear here that it is not linearly separable.
Yeah, clear. Since there is no linear plane that we can draw on the surface, right?
Yes, yes. Okay, we come to this question. Consider two data points x1 is equal to AA and x2 is equal to minus 1 into x1. So the data points x1 belongs to positive class denoted as 1 and the data point x2 belongs to negative class by 0. Suppose that a perceptron learning algorithm is used to find the decision boundary that separates these data points with the following rule. 1 W2x greater than equal to 0. The algorithm checks x1 in the first iteration and x2 in the second iteration and so on. How many times the weights get updated until convergence, that is the algorithm classifies both the points correctly. तो इसमें एग्जांपल ले सकते हैं कि x1 को आप 1 1 ले लीजिए, तो then x2 becomes minus 1.
इधर तो है कि x1 का जो a है वो a is less than 0, तो
ओके, सो ये minus 1 हो गया, ये plus 1 हो गया.
हाँ.
Okay. The data points x2 belongs to negative class. Suppose that the perceptron learning algorithm is used to find the decision boundary that separate this point. Checks x2 in the second iteration and so. So ये तो linearly separable आपके first iteration में हो जाएंगे ना, जो first update होगा, will find some boundary कहीं पर भी. आप कुछ भी initialize कीजिए.
x1
हाँ, तो they are linearly separable and in the first update only it will find. आप कुछ भी अपडेट क्या, फॉर एग्जांपल आई जस्ट
x1 सही डिफाइन है, x2 नहीं कर रहा है, उस केस में अपडेट होगा, देन दे आर लीनियरली सेपरेबल.
या इसका बेसिकली ये है, आई जस्ट you take any weight vector, x1 is here, x2 is here, you take any weight vector here or here or here, आपका जो अपडेट होगा, update will be in the first row only and it will make a decision boundary because they are linearly diagrammatically they are opposite geometrically. So in the first update only they will get updates will that will converge. Okay, this is a question. A team has a set that contains 1,000 samples. ये थोड़ा डिफरेंट टाइप क्वेश्चन लग रहा है ना पूरा यार.
They are different, but till now the concepts are relatively simple, except for that week 5 question.
Yes, yes. So a team has a data set that contains 1,000 samples. 1,000 samples. Gradient forward. Suppose they decide to use gradient descent algorithm to update the weight. Suppose they use the search algorithm for the learning rate n is equal to 2. How many times do the weights get updated after training the network for 20 epochs? So 20 epochs में for the weight update the loss has to decrease. So लाइन सर्च में तो हमने देखा था ना कि दोनों के लिए अपडेट लेता है, 0.01 के लिए भी लेगा और 0.1 के लिए भी लेता है. And if we consider this as a, for example, vanilla 1 gradient descent, so 1 epoch, 1 update for n is equal to 2, 1 epoch is equal to 2 update. Therefore, for 20 will become 40 updates. Is this understanding very correct? Somebody wants to contribute? Hello?
आंसर्स क्या दिया उन लोग ने ऑप्शन में?
Yeah, that is. 20. What is the
Sir, your voice is cracking.
okay? Why I'm asking that why it is not line search में line search की concept पढ़नी पड़ेगी हमें.
We have to revise line search, I guess. Which should be week 5,
Line
right?
search. Does it update
Week 4, sorry.
only once with an where loss decreases the most? I think ये था कि at every this it will use and this also and जिस n से इसका value decrease ज़्यादा होगी उस n को लेगा.
In one epoch, they are considering all the samples together, right?
Yeah, one
So there is
update
only one date.
with one n. Line search, he has got, for example, he can have 3 also, he can have 4 also. N can be anything 0.1, 0.01, 0.0001. But update it will use only which is giving the loss is decreasing the most. This is clear? Okay? I just opened my notes. I found that. Can somebody open the notes again that it is given line search wala? I'll tell you where it was covered. Am I audible again? Abhi?
Line search is in, I think, week 3.
Yeah, week 3 and they have covered it also. I'll just open.
Line search, bunch of learning days.
Yeah. Line search is update W using different values of n and retain that updated value of W which gives the lowest loss. So my understanding was correct. So this part which I have written, it is correct. It uses all n's,
Okay.
but it updates only where the loss is the lowest.
मतलब n में कितनी भी वैल्यूज होती हैं, जिस वैल्यू में वो मिनिमम देगा वहीं पर हम उसी के लिए अपडेट करेंगे.
Yes, yes, yes. So they have asked it as concept question.
Okay.
So here they have written update W using different values of n and retain that updated value of W which gives the lowest loss. So at every step we are trying to use best n value from the available choices. And इसका code भी उन्होंने check किया था. Okay, we go to. So this is the same question I think which we just solved. ये इसमें पैरामीटर्स हैं, पैरामीटर्स निकालने. ये तो निकाल सकते हैं तो straight away. Shall we calculate this? Yeah, that we can do. And suppose that a softmax function is used in the output layer to compute the y is equal to this. So this is the straight away question. Similar question we just solved. Here A4 value is different. So this we have done. Suppose the number of classes is 500. That is y hat belongs to R500. Suppose further that all elements in A4 is 1. Compute the y hat as follows. Softmax. ये भी निकाल सकते हैं.
हाँ.
Yeah. सो इसका स्ट्रेट अवे है कि अगर A4 की वैल्यू 1 है, ऑल आर 1, देन y hat will become 1 by 500, 1 by 500, 1 by 500.
हम्म
है ना? इसमें y की वैल्यू भी दी है, y.
देन वाई
What is the value of third element of y hat? Y hat as follows. Enter the sum of the elements of y hat. So 1 by 500, 1 by 500, उसका फिर
तो
हम
500
सॉफ्ट मैक्स निकाल के enter the sum of the elements in y hat. इसको निकालेंगे? What is the understanding of this question? A4 क्या था? A4 का dimension is A4 is 1, 1, 1, 1. इसमें तो A4 भी फैक्ट हो जाएगा.
सॉफ्टमैक्स अगर 1 by 500 1 by 500 दे रहा है तो सम ऑफ 1 by 500 टाइम्स तो 1 ही हुआ ना.
हाँ वही होना चाहिए.
हाँ, तो आंसर वही है 9 एंड 1.1 के बीच. हाँ
ओके 1 by 500, 1 by 500 और इसका या ठीक है.
तो सम
और इसका
हो गया.
सम हो जाएगा. ओके ठीक. ये आई थिंक हमने कैलकुलेट किया जस्ट नाउ मॉर्निंग में वाला क्वेश्चन. 0.25 हमारा तो 0.25 आया था. इसमें कोई डिफरेंस है क्या इसमें? इसमें यहाँ पे H3 इन्होंने -1 यहाँ पे 1 कर दिया है, वहाँ पे -1 था, if I'm not wrong.
वैल्यू
No,
डिफरेंट है
H3 is the same. H3 is the same.
सेम है.
1 1 -1 1 था.
तो हमारा तो गलत आंसर आया फिर यहाँ पर.
अरे डिस्कोर्स पे ये क्वेश्चन पोज है, वो आंसर की में आंसर गलत है. 0.25 है.
Are you sure? पक्का?
लिंक या लिंक शेयर
ओके ठीक है. Then we consider a single neuron with activation function phi of this as shown in the figure below. Here B denotes bias, Z denotes the input to the activation function, and Y hat is the output function. For all the calculations, take the true label y is equal to 0 and clip the gradient value to 0 if the value is smaller than 10 to the power minus 5. Truncate the intermediate results to 2 decimal digits, that is, if the intermediate is truncate of plane. Suppose that all the elements in the input are 1 and all the weight values are 0.1 and B is ये क्या कंफ्यूजन है? B is equal to W1 is equal to W2 is equal to Wn is equal to 0.01.
यहाँ पे सारे वैल्यूज को 0.01 कंसिडर करने बोले हैं. शायद नॉर्मल न्यूरॉन की तरह कैलकुलेशंस है.
या इसको खोल लेते हैं.
पहले वो सारे W के साथ एक्सेस को माइनस करने हैं और फिर V को करके Y हैट निकालना है और Y ट्रू वैल्यू इन्होंने 0 दिया हुआ है तो फिर उसके मदद से स्क्वायर एरर लॉस निकालना.
Shall we calculate this? X n is equal to 1. लेकिन यहाँ पे वेट एंड
यहाँ पे जो n इज इक्वल टू 10 है इसका कोई काम है क्या? n इज इक्वल टू 10.
हाँ इसका निकल पाएगा ना यहाँ पर. My doubt is this, that okay, they have written weight values as 0.1, and thereafter they have written B is equal to W1 is equal to W2 is equal to Wn is equal to 0.01. So there is a contradiction here.
Oh yeah, correct. I didn't see that.
है ना?
हाँ, इनके खुद के क्वेश्चन में ही तो कॉन्ट्रडिक्शन है.
Yeah. So, but we can calculate okay, considering, for example, x1 to x10, and we write 1, 1, 1, 1, 1. And for example, if W is 1, 0.1, and if we say this is 0.01, so this will become 1 into 0.1 into 10 plus 0.01. 10 into 0.1 plus 0.01, 1.01. And then we are saying that here they are using sigmoid in the question. Sigmoid निकाल लिया. So sigmoid of 1.01. इसकी वैल्यू किसी को पता है क्या कितनी होती है? कहता कुछ 0.73 होती है, 0.98 होती है. I remember correctly. So ये हो जाएगा अपना 0.73. And here they wrote actual y they have given it here.
Yeah, actual y is given to be y is equal to 0.
So y is equal to 0. So what they have asked in the question, enter the number of weights that will get modified from their current values during the next iteration. So our y hat is equal to 0.73, y is equal to 0. So after 10.11, basically 10 weights and 1 bias will get updated. 11 values will get updated. In the previous question, if we change all the weight factors to 10, that is B is equal to W1 is equal to 10, then enter the number of weights that will get updated during the next duration. तो उसमें अगर ये 10 कर देंगे तो क्या होगा इसमें? अगर इसको 10 कर देंगे तो ये जाएगा
एक बार पार्ट फिर से बोलिए. आफ्टर
100.
फाइंडिंग द कॉस्ट आपने क्या किया?
They are saying that if we change all the weight values to 10, that is bias and all the weights. Previous question, they are asking the number of weights that will get modified from the current values during the next iteration. So there are 10 weights and 1 bias, so 11 values they will get updated because y hat is not equal to y.
एक लॉस होगा तो
Since y hat is not equal to y, we will update all the parameters.
Okay.
Yes. And in this case, second case, what will happen if all are 10 and x is this? So this will happen summation 10 to 1 plus 10, 100 plus 10, 110, 110. Sigma of 110 is equal to is equal to 1. So in this update should take place. Can anybody amplify this?
Also, y hat didn't match the y.
Yes.
So it says the number of weights that will get updated. Shouldn't it also be 11?
Yes, it should be 11 because y hat is not equal to y.
check in discourse whether this option is wrong.
Yeah. Can somebody check, please? Okay.
Yeah, if anybody has raised this query before.
In case y is equal to 1 instead of y is equal to 0, then both answers will be correct here. In first 11 and the second 0. But this our understanding is correct. Ekdam we are doing. Can somebody check on the discourse, please? Okay.
This question I couldn't find in discourse, but the next question they are saying its mark is wrong.
Hmm. Okay. Move to next question. For understanding the previous question, if we change all the weight values to 10 and also the activation 5 to ReLU, then the enter the number of weights that update during the next action. What happens for the ReLU? In the ReLU function is what it like. It is like this. It is like this. So Z is equal to 110. Y hat is equal to ReLU of 110. So this will be 210 and y is equal to 0. So again the update should take place.
So all 11
So again,
parameters were updated.
yeah. So this second question again has got some problem. I think here by mistake they have written y is equal to 0. For these three answers to be correct, y has to be 1. We go to next question. An MRI image. This we have done. Okay. An MRI image of size 250 into 258 is feed as an input of the CNN. Suppose that we want to produce an output of size 119 into 64 using a set of candle. Suppose the candle size is 13 into 13. What is the value of stride? P padding is equal to 0. How many parameters? So these are the two questions we have to find. Value of stride, and we have to find the number of parameters. Okay. So this we can calculate easily. This is 250, 258. Kernel size is 13 into 13. The output 190 by 190. And this being 60. So we have to find first S is equal to what? The directly formula W is W1 plus 2P on S plus 1. Therefore, 119 is equal to 250 minus 14 is by S plus 1. So 118 S is equal to 7. So that's equal to 37. 118 is equal to 2. Now, number of will be how many?
$59. Oh, sorry, 237 divided by
13 into 30 into 8 into 64. Can somebody calculate this?
Eight six 528.
86 calculate. So can you
Then
check
we
the
have
answers?
to add bias also, na 64.
64
Hmm.
is my
Plus 64. Then answer is 86592.
8692.
Hmm.
Yeah. Start with
And its wide is 2.0.
Start is 2.0, yes.
Hmm.
Okay. Suppose the input is 250 to 250 to 3 into 8. And suppose further the cutoff size is 13 into 13. How many parameters are there in the lead?
Then we have to add 3 also.
I think we'll have to take this 8 also.
64.
Then it will become, if it has 4
2596.
dimensions, 2, 5,
259648.
yeah. We multiply the kernel size to this 3 into 8 and then add by that here to 64. Hello. Next question, that is stated that max pooling with step 2 reduces the number of parameters of this false because they are max pool.
I think his internet's gone.
Hmm.
ये कौन से टर्म का पेपर था?
और September 22.
ओके.
Hello.
Hello.
Hello. Hello. Hi, Abir. Hello.
Yes, sir.
Yeah, sorry, I had got disconnected. I had
No
just
problem.
got disconnected.
Yeah.
So where were we? We had calculated this here. So there is no problem regarding the CNN part here. I
Yes.
hope so.
Can we
We
just go to the parameters question, the two questions before this, please, for 2 seconds?
Yes. Yeah.
Yeah. Screen is not shared.
Okay, just hold on. My this Jamboard is shared. Can you open the Jamboard?
1 second. Yes. No, Jamboard is not shared. You have to share the link again, Alice.
Okay.
I'll just go to the Jamboard. I have the question paper open as well.
Yeah. Okay, pasting in the chat.
Yeah.
Yeah.
Yes.
Okay. So see, for the first part here, the parameters, this was 8 and we changed it to size 119 by 119 64.
Yes.
So here we calculated S हमारा निकला था 2. Now for the parameters will become 13 into 13 into 8 into number of these layers 64 plus
64.
there will be a bias which will go all 64.
Yes. So plus 64.
Yes. So this was the
Okay.
answer.
Understood.
Okay. In the second part, he said that if the image size becomes 250 into 250 into 8 into 3, there is another dimension 3.
Acha.
Then number of parameters will become, then this filter also will become 3.
Yes.
Then parameters
13.
will become 13 into 13.
13 into 3 into
8 into 3 into 64 plus
8,
64.
64. Understood.
Is this correct? Somebody can help me in calculation part? I'll just calculate it. So 169 into 8 into 3 into 64 plus 64. 259648.
64 plus 64.
And, yeah. So answer is
259648.
yeah. And the next question is that a statement that applying max pooling with the stat 2 is equal to reduces the number of parameters by half. It is false because there are no parameters in max pooling.
Okay. There are no parameters. There are no parameters.
Now, next question, consider the sentence expert is the one. We have to build the vocabulary that we can do that.
Yes.
Okay. We come to this question. This question is slightly trickier here. So this will solve.
Cut in this bag of words.
Yeah. So we read the question paper first. Suppose CBOW shown is to find a distributed vector representation for all the words in the vocabulary. The size of the V is 20. For all the words in the vocabulary are on one hot coded as a column vector and fed as input to the network. The output layer uses softmax to produce the probability score for each word given the context. So what he's saying, the size of the vocabulary is 20 and all the words in the vocabulary are one hot coded and fed as input to the network. So we know the CBOW concept. The CBOW concept is we feed words. This is the inner layer and
Yes.
we maximize for one word.
For one word, the probability of one word.
This is CBOW.
Yes.
Here is the word's context and here is the word's words. Okay. So now let's see the questions. What are the questions? Now based on this,
There was the dimension. Yeah,
how
number of
many
parameters.
number of parameters are there in the network excluding bias? So the size is what vocabulary 20. The size is 20. So one word will be represented. It will have 20 size,
Yes.
20, and he is saying that all the words are fed.
Hmm.
Okay, and now let's see what is the inner layer. Inner layer is 5,
Yes.
and here it will find 20. So here this becomes
Yes.
20 into 5, 100.
Yes. And there it becomes
Here it-
20 into 500.
Here it will become 20 into 5 into 20.
Into 20. Correct.
100, 2000. So as per my understanding, it should be 2100. Let's check. What is the answer?
It's 200.
How many parameters are there in the network excluding bias? How many network are there in the excluding bias? The size of the vocabulary is all the vocabulary are hot coded and fed as input to the network. So instead of this, I'll just use here this word which is there, it is one word. So here its dimension will be like 001 00000, and here what
Yes.
they are feeding all words 11111. So this also
Ah.
becomes 20. Okay. Whereas in the n-gram, what would have happened if we are feeding one word, inner layer,
One word.
then we
Yeah,
are selecting 4 words.
Yes.
So in this case, it would have become different.
Yes.
Okay. We go to next. How
20
many
into 5
parameters
plus
we
20
selected?
into 5 into 20 into 4 for
Yeah.
skip gram.
Okay. The word representation for the third word in the vocabulary corresponds to. So see, this word context which is coming. So this 111, this corresponds to first word. This corresponds to
Yes.
second word. This corresponds to
This
third
is
word.
third
And
word.
third word, this matrix which will be there, the third word will represent to the third column.
Third column. Third row, third column.
Yeah.
Yes.
Okay. The prediction y hat w is given by this. You see uw. The UCW is a dot product between a vector from W context and a vector from this. Then the statement that the neurons in the hidden layer do not have any non-linear activation function is non-linear because we are using here, this is a linear. Here we are using the softmax in this.
Yes, softmax.
Okay.
Correct.
Yeah. Yeah. Now we come to RNN. Consider a recurrent neural network shown below. X0, X1, X3. These are tan velocity function. Phi is tan, and here it is using velocity function. The initial weight values are as this. Based on this, इसमें calculation करना पड़ेगा. करें इसको?
करते.
Okay. In the meantime, let's see the questions. What are the questions? What is the mean square error loss? MSC दे रखा है इन्होंने, वो निकाल लेंगे. और इसमें आउटपुट इन्होंने दिया है. What is the value of y? Y is equal to 1. Okay, so we have to calculate. Then what is the loss? Update the parameter using plain SGD algorithm with n is equal to 1. Enter the updated value of v का निकाल लेंगे, कोई प्रॉब्लम नहीं है.
The output function is logistic.
Logistic function. So we calculate this, है ना?
Yes. Initial weights v equals to 4, w equals to minus 2, v equals to 1, s equals to 0. Full label y equals to 1. Okay. Okay.
S0 इन्होंने 0 दिया है. S is equal to 0.
हाँ, s equals to 0. S which w is minus 2 into 0 plus 4 into x t 0.1. Zero. Minus 1.2. Now,
tan h of 1.2.
tan h of 0.4 भी है ना?
हाँ.
tan h 0.4. 1.2 is 0.83. Okay. Zero point 0.31 divided by
0.04 आता है.
oops, that Yes, 0.048. Okay. So what is our main point? The parameter is 0.69. So 0.69 minus 1 and 0.69 0.69 0.66. I got minus 0.055.
हाँ
Okay. And so
ये आंसर आ रहा है देखिए चेक हाँ
what will be the
loss
learning rate? 1.
हाँ 1 दे रखा है हाँ ठीक है हमारा आंसर
Okay, okay.
वाह वाह दोनों
Okay,
आंसर
बराबर है?
ठीक है हाँ लॉस भी हमारा ठीक है और देखिए
0.048.
Yeah.
Okay. Good.
Computation भी heavy है
Hmm.
which of the following statements are true about vanilla RNN vanilla RNN it is prone to vanishing gradient problem it is prone to exploding gradient problem both
Yes.
we explained
Yes.
so with this we have finished it yeah any question anyone
No, no question.
so I decided to